Hey everyone. In today's video, I'm going to walk you through what a typical Python development experience looks like in VS Code. This is a follow-up to my previous video where I showed you how to install both VS Code and Anaconda. In this video, we'll dive into setting up a Python project, installing some essential VS Code extensions for Python, and creating a virtual environment to manage external packages. On top of that, I'll be showcasing some of the powerful features that VS Code offers to improve your workflow. Let's get started. First, let's go ahead and create a new folder and open it in VS Code. Start by launching VS Code, then navigate to File, Open Folder. Create a new folder and name it VS Code Demo. Once the folder is ready, select it and open it directly in VS Code. Once we open the project, let's take a moment to explore the interface. By default, VS Code opens up a welcome window when you start a new project. Here, you can create new files, open existing ones, or view a list of recent projects you've worked on. Let's go ahead and close this for now. On the left-hand side, you'll notice the main navigation tabs. The first one is the File Explorer tab, where all your project files and folders will be displayed. You can easily create, edit, delete, and organize these files by right-clicking or dragging and dropping directly within the interface. Next up is the Search tab, which lets you search for specific files or text within your project. After that, we have the Source Control tab, which is used for version control, typically with Git. This will be essential as your project grows, helping you track changes. Since using Git involves version control knowledge, I'll be covering that in a future video. Then there's the Debugger tab, which is a powerful tool that allows you to debug your code, stepping through it line by line and showing the active variables in memory. And lastly, we have the Extensions tab, where you can explore and install a variety of community-built extensions that can really enhance your coding experience. Another essential part of the interface is the integrated terminal, which isn't located on the left-hand side. You can open it using the shortcut Control backtick or by navigating to View-Terminal from the top menu. This terminal allows you to run commands directly within VS Code, making it convenient since you won't need to switch to an external terminal. Before we dive in, let's make sure we have the Python extension installed. I showed this in the previous video on setting up VS Code and Anaconda, but I'll quickly walk through it again here. Head over to the Extensions tab and type Python into the search bar. Once it pops up, click Install. This will automatically install 3 key extensions: Python, Python Debugger, and Pylance. These tools offer a range of powerful features that make Python development easier, and we'll explore some of them throughout the video. Additionally, we'll be installing the AutoPep8 extension, which is a handy tool for automatically formatting your code to comply with Python's PEP8 style guide. I'll demonstrate how to use it later in the video. Let's try running a basic Python script. Head over to the Explorer tab, right-click, and select New File, then name it test.py. Inside this file, let's write a simple print hello world. To run the code, you can either click the play button in the top right corner or right-click in the editor and select Run Python File in Terminal. If everything is set up correctly, the terminal will open and you should see hello world printed in the output. Awesome! That means Python is installed properly and we're ready to move on. When developing in Python, the first step is usually creating a virtual environment. Virtual environments are crucial because they allow you to manage dependencies and Python versions on a per-project basis. This isolation ensures that each project only has access to the specific packages it needs, avoiding version conflicts between projects. It also makes your projects more reproducible, simplifying the process of sharing them without worrying about dependency issues. Overall, virtual environments help streamline project setup, migration across different machines, and reduce the risk of package-related errors. There are 2 ways to create a virtual environment: using the built-in venv package or by using Anaconda and Conda environments. We're going to use Conda because it gives you more control, like the ability to select your Python version. If you don't have Anaconda installed yet, you can check out the first video where I walk through the installation process for both VS Code and Anaconda. To create a virtual environment, open the terminal and type conda create -n VS Code demo Python equals 3.11. This commands up a virtual environment named VSCode Demo with Python 3.11 as the base interpreter. When prompted, type Y to confirm and proceed. The installation of default packages may take a few minutes. Once it's complete, you'll see instructions on how to activate the environment. Activate it by typing Conda activate VSCode Demo in the terminal. You'll know it's activated when the environment name appears at the start of your terminal prompt. If you're using Windows PowerShell and don't see the Conda environment display correctly, try switching to the command prompt terminal. To do this, click the plus sign in the upper right corner of the terminal and select Command Prompt from the options. Now, you should be able to activate the environment and see that you're in the VS Code Conda environment. With your environment active, it's time to install some crucial packages. Run the command pip install matplotlib, numpy, pandas, scipy. These packages will be useful later. Matplotlib is for plotting, numpy handles numerical array operations, pandas works with Excel-like data tables, and scipy provides various mathematical and scientific tools. Let's also set this environment as the default for our workspace. Make sure you're working in a .py file. At the bottom right corner of VS Code, you'll see the current Python interpreter. Click on it to open the interpreter manager, and from there, select the environment you just created. Now, whenever you run a script, it will automatically use this environment by default. Now we're ready to start coding. One of the standout features in VS Code is linting. Linting helps by highlighting both semantic and stylistic issues in your Python code, making it easier to catch and fix potential errors before you even run the program. It can spot common mistakes like undefined variables, calling functions that don't exist, missing parentheses, and even more subtle problems like trying to redefine built-in types or functions. To demonstrate this, I'm creating a file called circle.py and pasting in some code that performs calculations for a circle. This code contains several errors. As you can see, linting immediately flags multiple issues: a missing colon after an if statement, missing indentation for the following block, the absence of a multiplication symbol between two variables, and missing parentheses in the print statement. With the errors identified, I can now go through the code and quickly fix each one. That wraps up what I wanted to show with linting. Let's move on to the next topic. The next features we'll explore are related to editing. The first feature is autocomplete and IntelliSense. IntelliSense offers a set of code editing tools focused on code completion. For example, when you begin typing a function that we've defined, IntelliSense will automatically suggest completion options. Similarly, when you start typing a variable like radius input, it provides a list of potential matches. This feature works across all files in your current working folder and is also available for any Python packages installed in standard locations. Another helpful feature is auto imports. This feature automatically adds import statements as you type. By default, auto imports are turned off, but you can enable them by setting python.analysis.autoimportCompletions to true in your settings. To do this, go to File, Preferences, Settings, and use the search bar to find this setting. Once enabled, whenever you use a package that hasn't been imported yet, an option will appear to auto-import the package at the top of the file. For example, I use this feature when working with NumPy, Oz, and Pandas. The next feature we'll explore is code navigation. To demonstrate, I'll create a file called process.py and paste in some more complex code that smooths out a noisy sinusoidal signal using the savgol filter from the SciPy library. While editing, you might come across a function you've forgotten about, like savgol filter, and need a refresher on what inputs it requires. You can simply right-click on the function and select Go to Definition. This opens a new file that takes you directly to where the function is defined, allowing you to review its parameters and read the docstring for more details. Additionally, you can use Go to Declaration to quickly jump to where a variable is defined within your program, making it much easier to navigate and understand your code. These navigation tools save you from wasting time searching through files and help you quickly understand how your code fits together. By using features like Go to Definition and Go to Declaration, you can easily explore code, whether it's something you wrote or part of a third-party library. This keeps your workflow efficient, allowing you to focus on writing, testing, and improving your code instead of hunting for information. The next features are related to refactoring. These are a bit niche, but can be very useful in certain circumstances. The features are extract variable, extract method, and rename module. Let's head back to circle.py to demonstrate them. The extract variable feature allows you to replace all similar occurrences of selected text within the current scope with a new variable. You can activate this by selecting the code you want to extract, then either clicking the light bulb icon that appears or right-clicking and selecting Refactor. In this case, I refactor r squared into its own variable to reuse throughout the code. Similarly, the extract method feature consolidates repeated code segments into a new method. Just like extract variable, you can select the code to refactor and use the light bulb or right-click refactor option. These features help make your code cleaner and easier to maintain. For instance, I refactor the circumference calculation into its own method to demonstrate. The rename symbol feature allows you to rename all instances of a selected function, variable, or module within the current scope, updating it across your entire codebase. This is especially useful when you want to rename something throughout your project without having to manually edit each occurrence. To demonstrate, let's open the test.py module where I've imported the circumference function we defined earlier and called it. Now, I've decided I don't like the original name. Instead of manually changing every instance of this function, I can right-click and select Rename Symbol. I'll change the name to Calculate Circ. As you can see, the function name is updated not only in this file, but across all occurrences in the project. That wraps up the refactor-related features. By using these tools, you can efficiently refactor your codebase without the risk of introducing errors through manual changes. Now that we've gone over the basics of refactoring, let's move on to formatting. Formatting is crucial for making your source code easier to read and understand. By following specific guidelines like consistent line spacing, proper indentation, and appropriate spacing around operators, your code becomes more organized and visually accessible. While formatting doesn't impact how the code runs, it significantly improves readability and maintainability. Tools like AutoPep8 automatically enforce these conventions to keep your code clean and standardized. For example, let's create a file called format.py with some poorly formatted code. Here, the import statements are scattered throughout the file, and there's inconsistent spacing between blocks, making the code difficult to read. To fix this, I can select the code, right-click, and choose Format Selection. This will automatically apply Python's PEP8 style guide, instantly cleaning up the code and making it much easier to follow and work with. Now, let's dive into VS Code's integrated debugger, a powerful tool that helps developers troubleshoot their applications without leaving the coding environment. It allows you to efficiently identify and fix issues right in the code. For Python scripts, the easiest way to start debugging is by clicking the down arrow next to the Run button and selecting Python debugger debug Python file. Let's try running the debugger on our process.py file. Once we start the Python debugger, a movable window appears, allowing us to step through the code. Let's pause and go through the code step by step. As we proceed line by line, the debugger provides a variable view on the left-hand side, showing detailed real-time information about each variable. This is particularly useful because instead of using print statements throughout your code, the debugger handles this for you, making the troubleshooting process much more streamlined. One great feature of VS Code is the ability to customize its functionality to fit your workflow. A common customization is changing shortcut keys. Let's walk through how to change the shortcut for the toggle line comment action to Control 1. First, open the keyboard shortcuts interface. You can do this by either using the command palette with Control-Shift-P and typing Open Keyboard Shortcuts, or by going through the menu via File, Preferences, Keyboard Shortcuts. Next, in the search bar at the top of the keyboard shortcuts interface, type Comment. Find the command Toggle Line Comment and click the pencil icon next to it to edit the shortcut. When prompted, press Ctrl-Q to set it as the new key binding, and then hit Enter to save the change. If Ctrl-Q is already assigned to another command, VS Code will notify you of the conflict. You can either override the existing command or choose a different key combination. Overriding means the previous command will no longer use Ctrl-Q. Finally, let's test the new shortcut. Open a file, select a few lines of code, and press Ctrl-Q. The lines should be commented out, and pressing Ctrl-Q again we'll uncomment them. If it doesn't work as expected, go back through the steps to double check that everything was applied correctly. I encourage you to explore the other commands available and experiment with customizing them to suit your workflow. The more you tailor your environment, the more efficient and enjoyable your coding experience will become. A common format you'll encounter for Python code is called Jupyter Notebooks. Jupyter, formerly known as IPython Notebook, is an open source project that allows you to combine Markdown text with executable Python code in a single document, called a notebook. Visual Studio Code offers native support for Jupyter Notebooks, letting you create and run them directly in the editor, just like any other Python file. To get started, create a new Jupyter Notebook and name it plot.ipynb. In this notebook, I'll paste the code we used in process.py. Before running the notebook, we need to specify the kernel, which is essentially the Conda environment we created earlier. To do this, click on Select Kernel in the upper right corner of the notebook. You may also be prompted to install some extensions related to Jupyter Notebooks. Just follow the prompts and install them. Once the extensions are installed, you'll be able to select the Python environment and choose the Conda environment we set up. Now we're almost ready. You can run the first cell, but if this is your Conda environment's first time using Jupyter, it might need to install some additional packages. When a pop-up appears, simply click Install. It may take a few minutes, but once the packages are installed, you'll be ready to start running your code. Using Jupyter Notebooks directly in VSCode rather than opening them in a browser has its advantages, as it provides all the other tools we have mentioned in this video. We've covered some key features of VSCode, but there are many additional extensions that can further enhance your development experience. For example, One Dark Pro is a comfortable dark theme that's perfect for long coding sessions, while Material Icon Theme adds a rich set of icons, making it easier to visually navigate your projects. If you work with Markdown, Markdown Preview Enhanced allows you to preview documents in real time so you can quickly see how your notes or documentation will look when rendered. For Python developers, Auto Docstring is a great tool that automatically generates docstrings for functions and classes, helping you keep your code well documented. Excel Viewer enables you to view Excel spreadsheets and CSV files directly within VS Code, saving you the hassle of switching between applications. For web developers, HTML CSS support offers autocomplete for HTML classes and IDs from your style sheets, improving efficiency. If you frequently work with CSV files, Rainbow CSV highlights them in different colors, making them easier to read and edit. Lastly, VSCode PDF allows you to view PDF files directly in VS Code, so you don't need an external viewer. In this video, we've explored some of the powerful features that make VS Code an essential tool for developers. From linting and debugging to customizing your environment and using Jupyter Notebooks, VS Code provides a wide range of functionalities to streamline your coding process. With the right extensions, you can tailor the editor to fit your unique workflow, boosting both productivity and enjoyment. I encourage you to keep experimenting with the tools and extensions we've covered and discover even more ways to make VS Code work for you. Thanks for watching.